if there's a
Ma'am,
network issue. What,
yes,
Smriti?
ma'am. I have also, can you after you're done with teaching collusion, before you start the new chapter, can you please discuss a question, exercise question in the textbook, 5.13.
5.30 and
No, 5.13.
13. Okay,
Yes,
5.13. This one from
that one
NCRT
question.
back exercise.
Yes, ma'am.
Oh, I'll discuss. 5.13. Okay, see, so I was discussing that what is exactly collision. The collision means when two bodies are coming in contact with each other. Okay, these are two masses which are moving with different speeds initially. Now, physical contact here is not necessary that both the bodies are moving in contact with each other and pushing themselves and colliding. They can move, they can move with any velocity, and then they can come in collision. Collision means the net force of the system will be zero. Here, during the collision events, the net force is zero, means the internal forces, external forces are acting on themselves. Newton's third law is completely applicable over here. So the event is the collision event. This occurs initially, and finally they get separated due to different velocities. So their velocities can change, their velocities can be same, either of the velocities can change or both of them can change. Anything can occur, two bodies are colliding, what all are the possibilities? So for that, different cases are there. I have already written everything, so just remember the formula. Now, what is collision? Let us discuss this. See, collision is an isolated event in which large force acts on the body for a short duration of time. So I already discussed with you, if you both remember, we have done impulse, represented it with a capital J. Remember, impulsive force, we did force which acts for a very short period of time, like the ball hitting the bat. Yeah, are you able to recall, Neha? Oh, so similarly here also the force that acts is for a very short period of time. So collision is an isolated event in which large force acts on a body for a very short period of time. We call these as the impulsive forces, which results in the changes in their velocities, which just change their velocities. So here physical contact is not necessary. This is what I was referring to. It's not necessary. Both of the bodies are coming in contact and then only the collision is occurring. One can exceed the velocity and then collide. This can also occur, other can overtake it. So anything can occur, and there are various cases in here. If the mass of this body is very huge, what if the mass of the first body is very huge? What if the other body was at rest? This came and collided it, like the game we have, sneaker pools that we play. Long stick is there, you just throw one ball, all the rest of the balls are at rest, and the main ball strikes the rest of the balls. I think this is a kind of game. Pool we say, what is it? ऐसी कुछ है ना? So
Yes, ma'am.
there, yeah, so there, this is also a complete example of collision. So in collision, lots of things can occur. Now there are majorly two types of collisions, elastic and inelastic. Among each of them are divided further into 1D and 2D. Now 1D and 2D means like both the collisions are occurring across the x-axis only, same axis. Either the bodies are coming from two different ends or both were moving and colliding like this, but across only one axis. Other is the oblique one. Oblique one means when two bodies are colliding, and it's not necessary that if you have strike something with a certain velocity, it will move exactly in the same direction. Carom board, when the coins that we play are at rest, okay. So when the striker hits them, what happens? All of them just get transferred in different direction. They are just transferred in different direction. So that transpersing of the coins or whatever is it which we say, which is hit using the striker, they can move in different directions at different angles. So when different angles are there, you need to resolve, because some angle is they're in a plane. So you have to get it along either x-axis or y-axis. So there you require a little bit of resolution of vectors. It's very easy. Collision is an easy topic. Just follow as it is. Write the notes properly. If you have these notes written properly, it will be very easy for you to understand. Otherwise, it becomes a difficult topic. You have to derive everything in every formula. So just practice the class notes. They are sufficient for it. So this one is known as the head-on collision in the straight line one. Another is known as the oblique collision. Okay. Now differences between elastic and inelastic depends upon the kinetic energy, momentum and all. And they are also a perfectly elastic, perfectly inelastic collision. There's a condition. So these things I'll tell you later. Just write down the basics first, the introductory part, definition, and the types. Then I'll tell you the differences between elastic and inelastic. Because theory questions also come from this. Okay, please write it.
Can you give an example of physical contact is not necessary?
See, physical contact does not necessarily mean when the contact is when the collision occurs. So physical contact is not necessarily means when the forces are exerted. Like if the body A is there, this is a body B. Let's say both are magnetic in nature. So what will occur? What will happen? The body B, this magnet, bar magnet is there. This will pull it right towards itself, and then the collision will right like this. So when a force is being exerted, that is what is meant by that physical contact is not necessary. This is all before the collision. During the collision, obviously, collision without any contact is not an event. Okay.
Okay, ma'am. Not done. Done, ma'am.
All right. So see, what are the major differences between elastic and inelastic collision? Elastic collision uses all the conservative forces. Remember, we talked about the conservative and non-conservative forces. So in conservative forces, what did we discuss? That the work done is independent of the path traveled. It just depends upon the initial and the final point. So conservative forces are used in elastic, while the non-conservative forces, those are dissipative, which are not conserved, like your frictional force, viscous force, these are inelastic. So all the sets of non-conservative forces, which depend on the path traveled, they just don't depend on the initial and final point. Non-conservative depend on both initial and final as well as the path. So there is no loss of heat energy in the elastic collision because of the usage of conservative forces. Okay, no loss of heat energy, while there is a loss of heat energy in the form of heat, sound. Best example you can talk about is the friction force, gives us a very clear idea because we can use that in our everyday life. Then see, the momentum and kinetic energy are conserved here. Okay, while kinetic energy is not conserved here, momentum still remains conserved, but kinetic energy is not conserved here. So kinetic energy not conserved, momentum is conserved. Here both kinetic energy is also conserved and the momentum is also conserved. This is a major difference between both of them. So see, since kinetic energy is conserved, total energy remains conserved. Here kinetic energy is not conserved. So total energy is not conserved. Okay. F internal you can remove. Kinetic and total energy are not conserved. This is the major difference, and this difference is often asked in the exam to write. Okay, so what's the major difference? Elastic is uses conservative force, inelastic uses non-conservative force. No loss of heat energy in elastic, inelastic loss of heat energy. Momentum, kinetic, total energy, everything is conserved in elastic. Only momentum is conserved, kinetic, total energy, they aren't conserved over here. Write down the differences, then we'll come to the coefficient of restitution. Make it in a tabular form, write it a little properly, even better than me, because this comes in the exam to write. Okay, and remember this as well.
Okay, ma'am. And mom.
Neha, you?
I'm done now.
See, now the term coefficient of restitution. It's basically the ratio of velocities, okay? Velocity which is there before the collision, velocity which is there after the collision. So it's basically the ratio of these two. And using the value, why is it important for us? Using the value of coefficient of restitution, we can predict what kind of collision is there. See, when the value of E is coming 1, because see, by looking at the case or by seeing the question, it's very difficult for you to tell whether the kinetic energy is conserved or not, or total energy is conserved or not, or momentum. By looking at momentum, you'll have no idea because momentum is conserved in both of them. Best is you use coefficient of restitution. This is represented with a symbol E. When the value of this E is 1, this represents an elastic collision. When it is less than 1, whenever the value is less than 1, 0 point something like this, or a negative value, that depicts this is inelastic. Okay. Now, when you get the value of E as 0, that means perfectly inelastic collision, which is there in your syllabus. Now, perfectly inelastic means, let's say two bodies were there, they were moving, they got collided. Let's say this is 1, this is 2. And after collision, they are moving with the same velocities and they are still stuck together. 1 and 2, they are still stuck together. This is what is meant by perfectly inelastic collision. Bodies stick to each other and they move with a common velocity. So usually what happens before collision, there is the initial velocity of the body as u1, mass is m1. Initial velocity of the second body u2, mass m2. During collision, they collide among themselves. Here, the net force will be 0 after they have their individual velocities. So the relative velocity of approach, relative velocity means the velocity with respect to each other. So for relative velocity, we subtract the velocity. Okay. Now, here u1 is lagging behind. Then they'll never be able to coincide. They'll never be able to collide. So u1 has to be greater than u2 in this case. So we'll write u1 minus u2 here. Usually for the change in velocity, what do we write? Final minus initial, u2 minus u1 we write. But in this case, we'll write u1 minus u2. Because u1 has to be greater, otherwise it will never be able to reach m2. And there won't be any collision. That is what is meant by relative velocity of approach. Then you have a relative velocity of separation. Now the body V2 is moving ahead and V1 is lagging behind. So this time it will be V2 minus V1. The ratio of these two velocities is basically the coefficient of restitution. Velocity means the final ones will come first and then the initial one. So coefficient of restitution is, this is the relative velocity of approach, this is the relative velocity of separation. The approach, one is approaching. This one is getting separated. Okay. See, do you get this? Why it is u1 minus u2 and here v2 minus v1? Is this much clear?
Yes, mom.
Okay. So separation will be v2 minus v1 by u1 minus u2. So this is the coefficient of restitution, which is represented by coefficient of restitution, and it gives us various data about different kinds of systems that are there. One by one we'll start. Elastic collision in 1D we'll discuss, then 2D, then inelastic and perfectly inelastic. This is what we have to discuss. Please write about the coefficient of restitution.
Mom.
Chanidhi, have you also written?
Yes, mom.
Okay. So let's discuss the elastic collision in 1D. So before, during and after, so what we will do, momentum is conserved. So we'll write the initial momentum equal to the final momentum. Initial momentum means first body, its initial velocity, plus second body, its initial velocity. See, initial momentum of this, its initial momentum plus its initial momentum. Then its final momentum, its final momentum. So mass is m1, velocity is v1. So this will be m1 into v1 plus this will be m2 into v2. Okay, now see, if this is the case, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, let's just shift the things. This is 1 1, this is 2 2, this is also here, this is 1 1, this is 2 2. Let's bring one terms together, two terms let's separate. So I can say m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. Why did I do this? So that I can just take out m1 common. That gives me u1 minus v1. This gives me m2 v2 minus u2. Got it? So this is one thing. Now kinetic energy is also conserved in this. So I will say, see, if this is the body, its initial kinetic energy. Mass is m1, initial velocity is u1. So kinetic energy will be half m1 u1 square. Similarly, its kinetic energy, initial kinetic energy will be half m2 u2 square. Then final kinetic energy will be half m1 v1 square, and its final kinetic energy will be half m2 v2 square. So when you added half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. So half will be taken common from both the sides, half will be cancelled. We will get m1 u1 square. From here we will get m1 u1 square plus m2 u2 square equal to m1 v1 square plus m2 v2 square. Now again, one term together, two terms together if we interchange. m1 u1 square minus m1 v1 square, m2 v2 square minus m2 u2 square. If we take m1 common, u1 square minus v1 square. If I take m2 common, v2 square minus v1 square. Now here this is forming the identity a square minus b square. A square minus b square is a plus b into a minus b. This identity we can use. So I can say this will be m1 u1 plus v1 into u1 minus v1. This is equal to m2 V2 minus V2 plus V1 into V2 minus V1. A square minus B square I have used here. Okay. Now let's do one thing. Let's take the ratio of the quantity that we have taken here and the quantity that we have here. Okay. So what I'm doing, this quantity that I have taken here, M, basically this equation, not quantity. This is one equation, M U1 minus V1 equal to M2 V2 minus U2. So if I write here, see, M1, let me take this as my second equation. So M1 U1 plus V1, U1 minus V equal to M2 V2 plus V1, V2 minus V1 divided by, this side was M1, U1 minus V1, U1 minus V1 divided by, this side was M2, V2 minus U2. So this was M2, V2 minus U2. Yeah, I've made it like looking like this. This is V1 here. This is V2. This was V2 square minus U2 square. M1, U1 minus V1, V2 minus U2. I have written it here. 1. U2 square. So V2 minus plus, I have written U2 minus. V2 plus U2, V2 minus U2. Similarly, here also, this will be U2. I don't know why by mistake I wrote. See, I hope you're getting it. I wrote by mistake. This instead of U2, I have written V1. So this is U2 only. Okay. So brackets get cancelled. M1 will be cancelled. M2 gets cancelled. These brackets will be cancelled. So what is left? U1 plus V1 is equal to V2 plus U2. Let's shift. U1 minus U2 is equal to V2 minus V1. So initially, what did we discuss? This was the relative velocity of approach. This was the relative velocity of separation. So they are coming equal. Relative velocity of approach is equal to relative velocity of separation. So here, since they are equal, the ratio that comes here is U1 minus U2 by V2 minus V1. This is written as the coefficient of restitution, that is E. So sometimes it comes to prove that now why they are equal. See, we know this is the formula of E. So if they both are equal, it means what is the value of E here? If this is the statement that I am getting, so what should be the value of E? I am getting this. Also, I know this for 0, for 2, what? For which value of E do you think they can be equal in this formula?
1.
What, Sanidhi?
1.
1, definitely 1. So that is how we get E is equal to 1 for elastic collision. Okay, now have you both understood why E was taken 1 initially? So this comes as a derivation for elastic collision. Only in elastic comes. In space elastic, not in elastic. Under the heading of elastic it comes, okay? Elastic. This is often asked in the exam. These formula-based questions, this I'll tell you later. First, you write down the derivation. Class, just write this. I'm coming in just 5 minutes. Just type done here. I'm just coming in 2 to 3 minutes. Somebody will scroll it for you. Just type done. Please. First, tell me, is it clear to both of you till here?
Yes.
Neha? Okay, please
Yes.
write it.
Bob.
Neha?
Yes, ma'am.
Okay. So see, now when you put the values of velocity, there is you don't need to derive it. The value of the final velocity is given by u1, m1 minus m2 plus m2 u2 divided by m1 plus m2. Okay, this is for the first body's final velocity. And final velocity of the second body is given by u2, m2 minus m1. Wherever you have 1, replace it with 2. So remember any one of the formula, either you just make 1 wherever you have 1, that will become 2. So u1 m1 minus m2, so u2 m2 minus m1. Okay, plus 2 m2 u2, so 2 m1 u1. m1 plus m2 will be the same. So these are the two formula for the final velocities v1 and v2, which you should remember. Okay, let's see a question. This is predict the outcome of collision assuming it to be elastic. When it says the outcome of collision, it means initial velocities are given to you, masses are given to you, they are colliding. Collision is also elastic. All these things have been mentioned. Outcome means what will happen. So first we need to find out what's the final velocity. If I say v1 is 0, so what will be my outcome? What can I conclude about it? I can say, okay, the first body will stop after colliding and the second body moves with this velocity. That is what is meant by outcome. Okay. So we have to choose one side as positive and okay, it's given. In the question it says to take right as positive. When the directions are different, no class, keep in mind the concept of velocity is not changing. You are just studying something new. The older concepts are not vanishing. Two different directions of velocity, so we have to take one as positive, other as negative. So let's take this positive, so this will be negative. Now, for the value of the velocities, directly put it, we want to see how are these derived. These are derived using the same formula, m1 u1 plus m2 u2 and all. From there only we have it, but you don't just remember the formula directly. So if I have to get v1, I'll use u1 m1 minus m2. See, for masses here, when you have m1 minus m2 or m2 minus m1, this depends on the mass. Okay, eventually you take the masses difference as positive only. Okay, so plus 2 m2 u2 divided by m1 plus m2. So here I'll have to put u1 is this. See, this is u1, this is m1, this is u2, this is m2. Okay, so one of you tell Neha, what should I keep on putting? U1 is
Oh, the value of U1 is 5,
5, then
positive 5. Then M1 is 2 kg minus 4 kg.
yes, plus,
So, yeah, plus 2 into 4 kg into minus 2
yes,
and then divided by 2 plus 4.
perfect, divided by 2 plus. Now see, for these masses I was saying, masses will always be positive, okay? Difference between mass can never be negative. So if it is 2 minus 4, you can write, when you write minus 2, you can take the modulus. Alright, because velocity can be negative. Velocity can come anything, but masses cannot. So V1 will be, this is 2, means minus 2 is there, that is 2. 2 into 5 is 10. This is minus. So this we are going to put minus, okay? Minus 16. Divided by, this is 6, which is minus 6 divided by 6, that is minus 1 meter per second. Now, why this minus? Minus helps in the outcome. Okay, when we're talking about the outcome, this helps in the outcome. If I say, this is how we write. This much of the body from this much. Like this, this is how we write. 2 kg from here. 1 kg, this is an example how we write the final velocities. Okay. So final velocity will be this is minus 1 meter per second, right? So minus 1 means minus sign was for the left side. It means the body V1, that is V1 was your M1. V1 means the final velocity of the first body. So it moves towards the left with a velocity of 1 meter per second. This is what is meant by it. Okay, and when we say V2, see, this will be U2, M2 minus M1. Wherever you have 1, we'll just replace it. So this will be M2 minus M1 plus 2 M1 U1 divided by M1 plus M2. So see, yes, Sanidhi, can you fill up the values?
Ma'am, once again, let me on my video as well.
Yes, Sanidhi?
Yes, ma'am. Ma'am, U2 will be minus 2
Yes,
into 4 minus 2
correct.
plus 2 into 2, 2 into 5,
Yes, right. Divided by?
5 divided by 2 plus 4.
Yes, very good. Okay, so just the values you had to put. So U2 is minus 2, 4 minus 2 plus 2 into 5 divided by 2 plus 4. So this V2 is equal to, see, 4 minus 2 is 2. This becomes minus 4. And 4 into 5 is 20 divided by 6. That is 16 by 6. So we can reduce this. This will be only divisible by 2. So 8 by 3. 8 by 3 meter per second. So this is coming positive. Okay, so what can you control? I'll just make a change here. This is okay. 8 by 3 is matching. This is 13 by 2 towards left. This is 5. So 2 minus 4. This is minus 26. So 13 by 3 will be there. 13 by 2. This is minus 10. If this is minus 2, so this is minus 26 by 6. That is minus 13 by 3 meter per second. Okay, don't take the modulus then. For masses, just put it in the formula. Okay, don't take the modulus value. Do not take the modulus value, because eventually it is getting calculated for velocity. Answer will be incorrect then. This will be, or if I just, this is 13. So 2 into 3 is 6. This will be 13 by 3 towards the left. So this is what we can conclude, because this is coming negative. So minus 13 by 3. Okay, since this value is coming negative, that's why we are taking it minus 13 by 3. So final velocity of 2 kg body is 13 by 3 towards left, and final velocity of 4 kg body is 8 by 3 meter per second towards the right. Because this came out to be positive, and we chose that for right. And since this is coming out to be negative, and we chose that for left. Remember, just forget what I told about the modulus part. That was incorrect, which I told. Okay, just calculate it as it is by putting in the formula, and eventually, according to your sign convention, conclude. Now, few special cases are there that we have to discuss. Please write it down from here. Neha, I think you left while I was saying, don't take the modulus. Okay, when you are subtracting mass, whatever is coming, no, just put it as it is. If it is -2, put -2. All right.
Yes, ma'am.
I'm done. Done, mom.
Done.
Yes, mom.
Yes, ma'am.
See, let's see the special cases. Uh, if both the masses are identical, m1 is equal to m2. So in the formula where we had m1, m2, there we'll be just putting the value of m, no 1 and 2. So that will give us 2 m2 u2 by 2m. Here also m minus m makes it 0. So only 2 m2 u2 by 2m. 2m 2m will be cancelled. So v1 is equal to u2. Similarly, when you calculate it for v2, v2 will be equal to u1. Means the initial velocities are getting exchanged like this. It was moving, m1 was moving with u1 velocity, this was moving with u2. Now this is having u2, this is becoming u1. Like this, final velocities are getting interchanged with the initial velocities. This is one special case. Second is, if the second body is very huge, so mass of the second body is very huge, so first one is very less. So see, its initial velocity will almost be 0. And see, when we use the formula m1 minus m2, if m2 is very huge, then m1 won't affect it. m1 plus m2, m1 minus m2 will almost be equal to m2. If I have 1 kg mass and I have 1000 kg, my difference 1000 minus 1 or 1000 plus 1 will almost be equal to 1000. So we just equate it with m2 if m2 is greater. So v1 will be u1. This term can be written as just m2. Okay, this whole term m1 minus m2, this is just written as m2. So u1 m2 plus m2 u2 divided by 2m2. Okay, this is m1 plus, just by m2. So here the final velocity u2 will be 0. Why? Why is u2 0? Because m2 body is so huge, so it is not moving with any velocity. u1 comes, initial velocity is almost 0. The body is very huge. Just imagine one very small object and a very big, huge body. So u2 is 0. So that's why we get v1 is equal to u1. Okay, and when you solve, v2 will be u. Means initial velocities will remain as it is. There won't be any effect. It's like this is getting collided with it. It is bouncing back. This will still remain at rest. This will rebound with its initial velocity. Understood?
Yes, mom.
Okay. Then case 3, if m1 is greater, same thing. If you put it in the formula, if m1 is greater, same thing. v1 will be equal to u1, v2 will be equal to 2u2. So this completes with elastic collision. For these cases, put it in the formula of v1 and v2, which we have studied. Note it down. These help in reducing the calculations, and this is helpful in the theoretical questions also. Okay, write it. If time is there, I'll start and complete in elastic too. Inelastic is a very small topic. Anyways, from the next class, I'll start with rotational motion. Just revise circular motion class before coming. Circular motion we have done. In laws of motion, please revise that part, especially the initial part. Before dynamics of circular motion, just revise that. That all will be needed in rotational motion.
Done, ma'am. Done. Done.
Done?
Yes, ma'am.
Yes, ma'am.
Oh, all right. See, in elastic collision, there is conservation of momentum. So m1u1 plus m2u2 is equal to m1v1 plus m2v2. This will be still valid. The thing is that we have to discuss is perfectly elastic collision. Perfectly elastic collision means both the bodies stick together and move with the same velocity. Now, if I apply the conservation of momentum, initial is equal to final. So m1 u1 plus m2 u2 is equal to m1 capital V plus m2 capital V or small v means the same velocity. So from here, if I now interchange the terms, I can say m1, or in fact, let me keep it like this, plus m2 u2 is equal to, let me take v common. This becomes m1 plus m2. So what is this v equal to? m1 u1 plus m2 u2 divided by m1 plus m2. This is the final velocity. So this velocity is known as the common velocity in perfectly in elastic collision. This is just what is new in here. Elastic collision. Because above part is exactly the same. Okay. So see here also, if we have to calculate the final common velocity, and it's not given it's elastic or inelastic. So what we see are the bodies stuck together or not. So see, they are moving with the same velocity. That shows this is perfectly inelastic. Okay. So when I use the formula m1u1 plus m2u2 by m1 plus m2. So this will be equal to 2 into 5. Both are in the same direction. Plus this will be 3 into 2 divided by 2 plus 3. So this V is equal to 10 plus 6 by 5, which is 16 by 5 meter per second. This is our common velocity. Am I clear, class?
Yes, ma'am.
Yes.
All right. So the noting part you can do in the next class. Before the class starts, I'll give you time to copy. But revise it till the elastic one. In elastic, we can discuss. And one more thing. Oblique, I'll tell you in the next class. Time is almost up. This you can note it in the next class. So